Okay, so let's have a look at the first one. Given that line WV, okay, here, WV is here and YZ is here. Note here they are marked with this little marks. That means these two lines are parallel to each other, right? And then WZ is here, is parallel to VY in the diagram. Then ask us to find X. Okay, so we know this line is parallel to this line is parallel to this line, and then have a line like this. Okay, this angle is 140 degrees, right? And then this angle must be 40 degrees, right? And we know this angle is 3x. And there is another line here. This is a right angle, right? So note here, this is a straight angle, right? And we know that this angle is x. So that means, suppose this angle here is A, but let's call it B. Let's call this angle B. So B plus this angle, right angle, right? Plus 90 plus x equals straight angle is 180 degrees, right? So that means B is 80 minus x, right? So that's why B here is 90 minus x, right? Then we know that this line is parallel to this line. Okay, this line is parallel to this line. So that means this angle must be supplementary to this angle, right? So this angle is 40 degrees plus this angle. We know this angle equals this little angle plus 3x. So that means 90 degrees minus x plus 3x equals 180. So this gives us 2x equals 50 degrees. That means x equals 25 degrees. Okay. Mm-hmm. And a question like this is to use the property of parallel lines to find the angle. This type of question is called angle chasing. Okay. You'll see a lot of problems in this chapter. Okay, next one. Oh, okay, any questions?
No.
Okay, next one. Question 2. In this diagram, line M is parallel to line L, and the angles are marked here as follows. Find X. So note here, we have learned the property of parallel lines. So this line is parallel to this line. This tells us that there might be some corresponding angles or other pairs of angles we can use. So if we add a auxiliary line like this, then angle ABC is actually comprised of this angle and this angle, right? So let's say this angle is A and this angle is B. And first of all, do you know angle A now? This line, if this line is parallel to L, okay, from this point, we can make a line that is parallel to L, right? Because the Euclid's fifth postulate tells us if we pass this line, find a line, there must exist at least one line that is parallel to the given line L. So if this line is parallel to L, then this line is also parallel to line M, right? Okay, so if these two lines are parallel, then A and this angle here are same side interior angles, right? So that gives us A is 180 degrees minus 130 degrees, which is 50 degrees, right? Then as long as we can find B, it's easier to solve X. So what is B? Because L is, let's call this N. L is parallel to N, gives us this, and then N is parallel to M. These two parallel lines gives us B and X are actually alternate interior angles, right? So this gives us B equals X. And we know that the sum of A and B is 90 degrees. So this gives us X plus A equals 90 degrees, right? And we also know that A is 50 degrees. So X is 90 degrees minus A, which is 90 degrees minus 50 degrees. So X is 40 degrees, right? And I have checked your solution. Actually, you extended this line, right? But note here, we haven't learned anything about triangles, right? So of course, you can use the sum of the interior angles of triangle is always 180 degrees, right?
I think we did learn that though.
Yes, you have learned that at school, right?
No, and in this too.
No,
in the
we
last
haven't
chapter.
Yes, this chapter, the later part of this chapter is regarding the triangles, but we haven't learned anything about triangle yet. We have learned the first part of this chapter.
Okay.
Yeah, this is what we have learned. Does not state anything about triangles, right? Only states the properties of parallel lines and how do you decide lines are parallel, right? You can only use the properties of parallel lines to solve this problem, right? And next time when we have learned the properties of triangles, of course you can do this. But so far, please use what we have learned to solve questions like this. Okay. And this is actually doable just by using what we have learned. Okay. Any questions? No? Okay, next one. Find X and Y in diagram below. So this time, note these two little marks. That means these two lines are parallel, right? Okay, remember, you can use these little marks to mark the lines that are parallel. And then we know that, first of all, X plus Y must be 180 degrees, right? Because this is a straight angle. And if this angle is 118, these two angles are vertical angles, right? Vertical angles are always congruent. So this angle here, let's call it A. A is 180 degrees. Oh, sorry. A is also 118 degrees. Right? And we also know that A is actually congruent to Y, right? So Y is 118 degrees. So Y here is 118 degrees. And because the sum of X and Y is 180 degrees, so that gives us X is 180 degrees minus 118 degrees, which is 62 degrees, right? Okay, any questions? No? All right, let's see the next one. Okay, it asks you to show that angle A equals angle C and angle B equals angle D. So actually you have to prove that, right? You are given two pairs of parallel lines. So first of all, line AB is parallel to CD. Note here these pair of little marks here, and line AD is parallel to line BC because we have a pair of little marks here. So first of all, because line AB is parallel to line CD, that tells us angle A plus angle D equals 180 degrees, right? Because A and D are called same side interior angles, right? If you have parallel lines, then same side interior angles must be supplementary. And also, angle B plus angle C is, oh, actually we do not need this. So note here we have another pair of parallel lines because line AD is parallel to line BC, right? And this gives us another pair of supplementary angles. This angle must be supplementary to this one, right? So that means angle B plus angle A is 180 degrees, and this angle must be supplementary to this one, right? Because these two lines are parallel. You see that? This line is parallel to this line. Okay, therefore, angle D plus angle C equals 180 degrees. So let's call this 1, 2, 3, respectively. From 1 and 2, we know that if angle A plus angle D is 180 degrees, also angle A plus angle B equals 180 degrees, that actually gives us angle B must equal to angle D, right? You see that? So that successfully shows that angle B equals angle D. And how do we show this? Angle A equals angle C. That depends on number 1 and number 3, right? From number 1, number 3, we know that, okay, if A plus D is 180 degrees and D plus C is 180 degrees, that means A must equal C, right? Okay, so from 1 and 3, we know that angle A actually equals angle C. Okay, so this means we have successfully proved these two statements, right? Okay, if you have encountered a question like this, show something or show that or prove that, you have to prove it logically, okay? Not just say that it looks like these two angles are equal. Can't say that. You have to strictly prove why they are equal using what we have learned so far, okay? So what we have learned so far. How many axioms? How many theorems?
4.
Four theorems, right? 4 property theorems, right? Like that. And 4 property theorems and another 4 theorems, which are called judgment theorems, right? So judgment. And do not forget, we also learned the 5 Euclid's postulates, right? This is what we have learned so far. 5 postulates or 5 axioms. For postulates or axioms, you don't have to prove that, right? And 4 property theorems. For theorems, actually, we have to prove them. And actually, I have shown you how to prove them in our previous lesson. And another 4 judgment theorems. Again, we have to prove any of these statements. So that means 5 postulates and 8 theorems that we have learned so far, right? Okay. And as we proceed, we'll learn something more, such as the properties of triangles in our next lesson. Okay, next one. Do you have any questions? No, okay, next one. All right, this time we are given, okay, this line is parallel to this line, right? Because we have little marks like this, right? If we don't have this mark, although it looks like these two lines are parallel, do not conclude they are parallel because they are not marked that way or you're not given such information. So this diagram shows 2 lines with these pairs of marks. So that means these 2 lines are parallel. Then this pair of marks tells us these 2 lines are parallel, right? So we have 2 pairs of parallel lines. And then this angle is given, which is 3x plus y, right? And because this line is parallel to, and let's call this M and N, because line M parallel to line N, so this angle is a corresponding angle to this angle, right? Therefore, this angle here is also 3x plus y, right? And then this angle here is the corresponding angle to this angle, right? Because this angle is 2x minus y, so this angle must also be 2x minus y, because when this line, let's call this P and Q. When P is parallel to Q, this pair of angles are called corresponding angles. Corresponding angles are always congruent. So this angle here is 2x minus y. Then this angle is 3x plus y. Then because this angle is a straight angle, right? So that means 3x plus y plus 2x minus y equals 180 degrees, right? And luckily we can cancel the y here. This gives us 5x equals 180 degrees, right? So that gives us x is actually 36 degrees. Okay, so because it only asks us the value of x, so we don't care the value of y. Y could be anything that is legible, that is legit. Okay, next one, in the diagram at right, in the diagram below, line K is parallel to line L. Okay, so we are given line K parallel to line L like this, and line M, which is here, is parallel to line N. Okay. Also, two pairs of parallel lines. And then, if the angles are marked, find x and y. Okay, so this time we need to find both x and y. Okay, another angle chasing problem, right? Okay, because this line is parallel to this line, we know that this angle here is the corresponding angle of this angle, right? So this angle must also be x minus y. So apparently these two angles, the sum of these two angles, which is x minus y plus x plus y, must equal 180 degrees, right? So this cancels the y. That means 2x equals 180 degrees. Okay, first of all, we have solved x is actually 90 degrees. Okay, next, let's use another piece of information to find the y. Okay, again, because line K is parallel to line N, so these two angles, let's use another color, these two angles here must also be corresponding angles, right? Okay, so this angle is x plus y. This gives us this angle is also x plus y, right? And because line M is parallel to line N like this, so these pair of angles are also corresponding angles, right? Corresponding angles are congruent, so we have 2x minus 2y must equal x plus y, right? So this gives us 3y equals x. X has been solved to be 90 degrees. So this means y must be 30 degrees, right? Okay, and again, you can see we have used the properties of parallel lines to find the corresponding angles, or sometimes alternate interior angles, or sometimes same side interior angles for any angle chasing problem. Okay. Basically, it's the application of the first three property theorems. Okay. Okay. Any questions? All right, next one. Find x in the diagram below. Okay. You tell me, can you see any parallel lines in this diagram?
No.
No, because it doesn't tell you any parallel lines here, right? And also it doesn't mark any parallel lines like this in the diagram. So first of all, you don't know if two lines are parallel or not in this diagram. if you want to use the properties of parallel lines, first of all, you need to prove if any two lines are parallel, right? So can you do that? Seems that we can, right? Because this angle here equals this angle here, right? And note here, this line here is the transversal of these two lines. And this pair of angles is actually called, what do they call?
Equal.
Yes, but do you remember the names of this pair of angles? Alternate interior angles, right? Because we have alternate interior angles which are congruent. So you can say angle ABC equals angle BDE. Because the alternate interior angles are congruent, according to the judgment theorem 2, right? You can say these two lines are parallel. Let's call line AB is actually parallel to line D. Okay, then if we have two parallel lines, then we can use a property theorem for angle chasing. Because we want to find x, it seems that we can use this angle, right? Because if you have two parallel lines, then first of all, this is x, right? Because this is a transversal line. Because this angle is a vertical angle of x, so this is also x. And then because this line is transversal, therefore this angle here is also x, because these two angles are also alternate interior angles, right? So that means x plus 122 degrees must equal a straight angle, right? Which is 180 degrees. That gives us x is 180 degrees minus 122 degrees, which is 58 degrees, right? So as you can see here, these two angles are used to prove this line is parallel to this line, right? And after that, if you have already proved this line is parallel to this line, then you can use a property theorem to find any angle that is related to x, right? So these are two different processes. Any questions?
No.
Okay. All right, next one. Okay, any thought on this? Have you ever met a similar problem? Actually, it looks like it's quite similar to this problem, right? So, any thoughts on it? What can you do? We're given this line AB parallel to line EF. And our task is to find angle W here. If you have only the right part like this, is it the same with the previous question? For example, if you are given only this part, does it look like the question we have discussed here?
No.
You can try create a auxiliary line, right? The new line should be parallel to either of the given lines. So we can try that. So for example, in order to solve W here, we can try to make a auxiliary line that is passing point D, which is parallel to line EF, right? We can make that, right? Because Euclid's fifth postulate tells us we can do this. Okay, because this line AB is parallel to this line. If we make a new line that is parallel to line EF, is it also parallel to this line, AB here? Sure it is, right? Because if we have two lines, and if you make a third line that is parallel to either this one or this one, it must be also parallel to the other line in this pair, right? And because this line is parallel to this line, so let's call this angle alpha. Let's call this angle A. That means, okay, let's make a point here. A, B, C, D, E, F. So how do we write this? We should write it. We can write it like this. Draw a new line. DF parallel to EF. Also passing through point D. And the new line DF must also parallel to line AB, right? This is what we have discussed, right? Okay, so because DF parallel to EF, and angle A must be the alternate interior angle to the 50 degrees here, right? So that means A must equal 50 degrees. Okay, so at least we have solved part of W here, right? And in order to solve this angle here, how about we draw another line here? Okay, we draw, let's call this G. Draw line CG parallel to AB. Then we have also new line CG, also that parallel to this line, right? DF. So we know actually these four lines are parallel to each other, right? Okay, so let's call this angle here B, because AB parallel to line CG. That gives us angle B is a alternate interior angle to 40 degrees, right? So that means B must equal to 45 degrees. Okay, so because BCD is angle BCD is 85 degrees, right? Therefore, let's call this angle C here. What is angle C? Angle C is 85 degrees minus the B, right? So what is C? Minus B. What is B?
45.
So angle C must be 40 degrees, right? Okay, we know that this angle here is 40 degrees. So let's call here is D. So what is angle D?
40 degrees.
is also 40 degrees. Okay, so can you see what is angle W?
95.
D plus A, right? Which is 40 plus A. A is 50, right?
90.
90 degrees.